Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, design circular queue. So in this question, basically this is a design question, and in the design questions, we are not only required with it optimize time complexity, but also are required to choose an appropriate data structure. So the appropriate data structure which could be used here is always as per the things which are being given to us, means all the conditions which are being given to us. So let us first read this question, then about the time constraints and space constraint, whatever constraints which are given to us, we are required to check, and then we will be thinking about that how we can implement this question. So let us get started. So basically, design your implementation of a circular queue. So not only the queue, but we are required to make a circular queue. Now, first thing comes up that how a queue is. Basically, a queue is C4 in nature, right? As it is already written here. So here you can see that the circular queue is a linear data structure in which operations are performed based on C4, the way in a queue is being performed, right? And the last position is connected back to the first position to make a circle. It is also called a ring buffer. So the thing here is that we all know that what a queue is, right? So stack is something like that we have put a pile of books, right? And a queue is something like that there are a lot of people who are being there, right? So whosoever comes first, it will be going out first, right? So that is the thing in a queue. So this is the same thing, first in and first out, right? So like this only we are required to maintain this principle also in this particular circular queue, but the only thing would be that they both are connected. We don't know who comes in first, who goes out first, but still we are required to maintain that C4. That will check that how we will be maintaining, but let us read ahead. Then it says that one of the benefit of the circular queue is that we can make use of the space in the front of queue. Because front and the end are connected, right? So that's why we can use the space which is being there in the front of the queue. Because when we are in a simple queue, right? So we simply pop out from the front of the queue, right? And because of popping out from the front side, there is empty space in the front, right? And the back side is already filled because there are elements in the same, right? So we can't use this front space, right? So that's why when we make it a circular queue, then it would be easy for us to use that space. So in a normal queue, once the queue becomes full, we cannot insert the next element even if there is space in front of the queue. So that is one of the problems in the normal queue. But using circular queue, we can use the space to show new values, right? So now this is the main question. Above one was just the overview that what circular queue is. So now here, implementation, the circular queue class. So here we are already given with the my circular queue class, and in this, these are the functions which are being there which we are required to fill up. This is the constructor for the class where every object would be initialized. Then we are required to implement these 6 functions: front, rear, enqueue, dequeue, is empty, is full. So these are the functions which we will be building up, and you must solve the problem without using built-in queue data structure in your programming language. So that is the thing. Now comes the part that is there anything in our programming languages. Let us first consider our C++. So in that, is there in data structure where we are given with some sort of, where we can circulate, means connect from the front to the end part, means connect both of them. Is there any such type of data structure? The answer is no, right? So we would be required to connect, means make such type of data structure from the existing data structure. So how we can do that is by taking an array. That could also be done, or by taking a linked list. That could also be done, right? In both of the case, thing would be same. And even the implementation way, means in both of them, the time complexity and space complexity which would be there, that would also be the same. Because Space complexity is surely same, because here we are using array and linked list, so it will consume n space for the n element which would be stored. At the time complexity, how it would be same is in array. See, when we are sorting something, right? So how we sort it? Either we use that, not sorting. The example is about the searching. If we search something in array, how we search it? Either we use binary search, that will become n log n, right? Either we use 2 pointers, right? So that will become n, right? So in that context only, if we take array, so how we basically push elements into the same, or how we basically take out elements from the same, that will define a time complexity. So from that manner only, by optimizing these things and by using some pointers and so on, we can easily make our array implementation also as order of 1. And in linked list, it will be already order of 1 only, because there are pointers and we can easily make that as the circular linked list. But array implementation is much more simpler, so that's why. And even the time complexity and space complexity is also the same, so we can go ahead with that implementation. So before going that, let me show you the explanation for the same. And then there is one more test case which can be a follow-up question in interviews, so that also we can go ahead with the same. So let us first go ahead with the first, and then we will go ahead with the follow-up. So now let us go ahead for that. So here comes the part. So this I have basically written, if this color is not good, then I can change it to black. I was just trying out. Okay, let me change it to black only. Yeah, now it's much better, because now it is visible. So now the functions which were being given to us. So now we have decided that we will be taking array as the data structure, in which we will be implementing all the functions. So now their first function was bool enqueue, right? So that simply means that we are required to put something into the same, right? But before putting anything into array, what we are required to check? See, we can only push into any particular vector, array or any data structure if it is having some space, right? If it don't have any space, then how we can put, right? So that is the first check. By implementing this particular function, we are required to check. So before putting any element, need to check that if it is full or not. That is the thing we will be checking. If yes, then we will be returning false. If no, then fill the value. So this is the straightforward thing. But beside these also, there are some more checks which we are required to implement in this function. So that is the thing. Basically, this returning of boolean and so on, this was basically taught in my company only to me. There only we are, I guess in various companies it would be like this only, that we are not returning the values, but we are returning the status of those things. So here on Leetcode also it is the same. So from there only I learned. So it's like when you are working in a company, then you get to learn a lot from your company. Means industrial experience is must for a person. So while filling, we need to fill at the tail and update positioning of the tail and update reset flag to false. So now what is reset flag? Actually at the starting, to make this array implementation as order of 1, I will be taking head and tail, 2 pointers would be there, and the flag would be there. So this reset flag would let us know that if our array is full or empty, because when our array is full, then also our head and tail would be equal, right? And when our array is empty, then also our head and tail would be equal, because it is empty and it is a circular, right? What I'm saying is, yeah. So our queue is basically circular, right? So when it is full, then also our head and tail both would be at same point, right? So here we are having all the elements. And when it is empty, right? So then also our head and tail both would be at same point. but at this moment it is empty. So that's the thing, both of the case would be same. So what will help us to determine that it is empty or it is full? So that thing would be basically one flag, and that's what I am taking here, and that would be reset flag. So when we would be enqueuing into our vector, so at that moment, see how we enqueue into a queue. We basically enqueue into queue by pushing that from the back side, right? And because of that only we are here updating our tail, and then we are also resetting our flag to false. That is the thing, so that we are able to check that now our data structure is basically not empty, but it is having some value. So that's why we are resetting it to false. Now comes the next part. So this was all about enqueue, where we are required to check that it is empty or not. That is the first criteria, so that there is no overflow sort of condition, right? Because even it is a circular, that's why we are required to check that it should be having some space. If it would have not be a circular manner, right, then we won't be required to check that, as in arrays, not in arrays, as in vectors, because it by default expands its size, right? But here there is limitation of k size, which only which we are required to use. So that's why we are required to check if it is full or not. Now comes the part for DQ. So in DQ, what DQ actually means is we are required to pop out some elements, right? So for popping out a particular element, first we are required to check that is there anything in our stack, in our queue or not, right? So here this is our circular queue. It is its head and tail are connected. Now first thing we will be checking is that is it empty or not. How we can check it is empty or not? By our empty function which is being there. How that empty function will be checking that are there element or not? It will be checking if our head and tail are basically pointing towards each other, means at the same point, and our reset flag is basically equal to true. So that simply means that our this particular data structure is empty. So that's the thing. Because of this reset flag only, we are able to check that if it's empty or full. And the other condition which is true for both is head and tail are pointing towards same pointer or not. Because head and tail would be pointing here, and our reset flag is the only way to let us know. And here we are making it false, and here we are making it as true. Then our head and tail, both of them are pointing to each other, and earlier it was false, but now we will be making it as true, because now it will be empty when both of them point each other. So here the thing is, this would be the thing that we will be checking, right? And then at this some more checks which are there is that we are required to update our head, and when we update our head, then only we get to know that after updating our head, does it points to our tail or not. If it points to our tail, then we will be resetting our reset flag to true. So that's the thing. So these were the two implementation till now. Now comes the part for front and rear. It is straightforward. For front, we will be returning what would be at the top, that is our head pointer which is being there, and for the rear we will be returning our tail pointer, right? So that would be the thing, but before that also we are required to keep a check that in front is it empty, in rear it is empty or not, in both of them. If both of them, in both of the cases are empty, then we will be returning false, else we will be returning our head or tail. So that's the thing. Basically these checks are at most necessity in implementation. These I learned from my company as well. Yeah. So here bool is empty and is full. So here the thing is, when it would be empty, when head and tail are pointing each other, right? So that's the thing, head and tail are equal and the reset flag is true. So that is one of the criteria because of which we are able to check that it is empty. So we will return true or false, and same goes for full. If reset flag is false, then it would be true, else it would be false. So that's the thing, and this is the simplest implementation for the same without the follow-up. So as you can clearly see that here we are just using that 2 pointers, because of which we are easily able to do this particular question in order of 1, right? Else it would have been in order of n only. That's the thing. Now let me show you the coding part for the same. After that we'll do the follow-up question for the same. So here's the coding part for the same. Yeah. So here what we are doing is we are taking this vector, which is the main portion of this in which we are storing everything. So here int head and int tail, these are the 2 pointers you can say, because of which we are accessing the starting and the ending point of a circular. Although in circle there is no start and end, but still somewhere at the, see, the thing is that when we are having a circular, so both head and tail would be at same point only, right? But when we are filling it, when we enqueue into the same, so our tail is here, right? But our head will be at the next point. And same it goes until it get back to at this position, right? So according to this only I'm saying about starting and ending. Now there is this reset. Because of this reset only we will be able to detect that it is full or it is empty. Now this is the first where this is the constructor where we will be initializing our whatever we are using. So at this point our size of the data, basically the vector, we are resizing it to k, right? And then our head and tail both are pointing at the starting point, so they are at 0. And here our reset is true because at this moment our data is empty, right? Then here we are implementing this function. So while implementation of this function, so first thing is that when we enqueue into the same, then at that moment we are required to check that if it is empty or not. If it is full or not. Empty, that we already require, right? So we will check for the full. So that's why here we are checking that if is full, then we will be returning false. Else we will updating our head pointer, because not updating our head pointer, but we will be checking that if head equals to tail, that is the starting point, and if our reset is basically true, that is it is at the true point, means starting point only, reset is the first element we are filling into the same. That's why we will be making our reset pointer as false at this moment. This simply indicates that now there is one element. And then updating our vector with at that index where the tail is being there, we will be putting our value there, and now we will be updating our tail by increasing it with +1, means incrementing the index, and then doing the modulo by size of the data. Why we are doing modulo? Because it is a circular, right? So the thing is that index would be increasing in such a manner that it will come to that position, like what I want to say is 1, 2, 3, 4, 5, right? This is a linear data structure. But when it is a circular, 1, 2, 3, 4, 5. So when we do modulo, then only it will come to this position when we do +2. But when we don't do modulo and when we do +2, then it will go to at 7, right? And because of that, it will show runtime error, because it will be accessing a memory which is not in our scope. So that's why it will show that segmentation fault, or you can say runtime error. So now comes the next part after this, because now this operation was successful till now, no false was there, so that's why it will be returning true. Now comes the next part for the bool DQ. So for bool DQ means we are picking it out, right? So first we will check that if it is empty. If it is empty, then we will return false at that moment, because there are no elements to get it out of the queue, right? And then if that was not the case, then we will be checking for this head portion, right? So now what we will be doing is, rather than getting that element out of the queue, we will be incrementing our head, because the thing is, when we do erase operation in vector, it is a costly operation, as when we erase any element, right? So because of erasing that element, we are required to pick that out of the vector, and also we are required to change the positioning of other elements, which takes order of n time. So that's why rather than erasing any element, what we are doing is we are just updating the position of this. Now our head will be at the next position. And why at the next position? Because we are assuming that we have already removed the first element which was there. So that's the scene. So that's why we are doing head plus 1 and modulo by this, so that it doesn't get out of the bound. And then we are checking that if our head and tail both are now equal, then we update that head, right? And the reset is false. False because of the case as why we were having that reset equals to false, because it was having elements, right? So now we will be making it as true, because when head and tail comes at the same position and earlier it was as the false, so now it simply means that now our queue is basically empty. So that's why we are making our reset flag as true. What I'm explaining here is, see, we are at this tail and we are at this head, right? Although there are elements in the same, means although there would be elements here, but we are changing the positioning of head so that we can let the user know that you can't access all those elements, you can only access at this point and this point. But when DQ is again called, so now head will be updated to this point, right? So now it is at this point only, and this is also removed. Basically elements are there in this because we are not removing them, but we are just changing the positioning so that those are not accessible. That's the thing. Because whenever we insert a new element, it will be inserted at this point and previous element would be overwritten. That would be the thing here. So when head and tail both come at same position, right, at this moment of point, so now what is the status of queue? We can't access any other element, right? So that simply means that it is empty for user as well, right? So because of that only, we will be resetting our flag as true. Means now our queue is empty. So that is the thing I am trying to explain. So that we will be doing at this point, and then because DQ was successful, so we will be returning 2 at this moment. Now in front simply means that whatever is at the head pointer's moment. So if it is empty, then we will return -1 because empty, so that means there are no elements, right? So when we are having something as the data point, basically at the head point, that we will be returning through this. And for the rare, we will be returning basically, first we will be checking that it is empty or not. If it is empty, then -1. And if it is not empty, right, so we will be returning data of tail plus data dot size -1. Why we are not only doing the data of tail? Why we are adding up data dot size -1 and then doing modulo with the same? So the thing is, because it is circular in nature, right? So we would be having, we would be there at that position there. Because of the circular in nature, we are required to add that size of the data, right? And then doing the modulo for the same, because the thing could be that it could be at any such position which is more than the limit. Means when we are incrementing it, right? So because of that, it could reach at that position. So that's why we are doing that modulo, and then adding up that is also in that criteria only, so that it is in bound of the indices for our case size. So that's why we are doing tail plus data dot size -1 and doing the modulo for the same. And then bool empty, this is directly that if head and tail are pointing to each other, and if our reset is basically, if it was true, that simply means that nothing is there. Yeah. So when true, then we will return true, else we will return false, and the opposite is the case for the full. So this was all for our first part. Now comes the part for our follow-up question, which could be asked by interviewers. See, this is the time complexity order of 1 and order of n space complexity. Order of 1, how it is, you can check that each method which we are using, right? there is nothing as such where order of n operations are there. Everywhere there is just order of one operations, right? So that's why that's the case. But now comes the part that what about that race condition, multi-threading system, right? So in that we are required to use mutex. So in that context only our implementation would somehow change. So here's the part for our next implementation. This is the follow-up for the same. That is when we are required to tackle the race around condition. But in this context, as we are using the arrays, so that's why time complexity will become order of n, and due to vector it was already order of n space complexity. Now as we are using here mutex, so now comes the part that how we will be implement this. So I've changed the implementation for the same. So here we are using the capacity and this mutex. So the thing is that first we are directly initializing the capacity with k, and then in the enqueue we are first locking our mutex at that point, and then we are checking if that q dot size, basically size of our queue is less than the capacity, that is we are having some space, then in that context we will be pushing to our queue, and then we will be unlocking because the operation was successful, so that's why we will be returning true. Else we'll unlock it because this if condition was not there, right? So it comes to else part or whatever was not inside this if, and then we'll return false. So this is our enqueue, and same goes for dequeue. There we will be checking that if our q dot size is basically greater than 0, right? If that is the case, then we will be basically erasing from the beginning part, and this erase operation is the only one which I was saying, which is taking the order of n. Else everything in this is basically order of one operation only this part is order of n. And then we will be unlocking and then returning true as operation was success. This is that unlock part when we were not entering this, but we had already locked, right? So that's why, and we will be returning false in that case. This is the front portion. So front portion is that one which we are returning from the front side, right? So here the thing is, we will check if our q dot size is basically greater than 0, then we will be returning the frontmost element, that is q of 0, else we will be returning false. And for red, again we will be checking that its size is basically greater than 0, right? So we will be returning q of q dot size minus 1, that is whatever is at the last, else we will be returning minus 1. So here is empty, that simply means that our size is equal to 0, or full simply means our size is basically equal to capacity. So this was the implementation which could be asked in the interviews as per the follow-up, and this is the one which is as per the race conditions in the multi-threading system. So this was all for this particular question. If you have any doubt about this question, you could comment that down, and I hope you like the explanation. I have tried to get it ready as per the interview perspective, because I know this would be much more helpful for everyone. Yeah, so this was all. If you like the explanation, please do like and subscribe to my channel, and do share among your friends. So this was all. Thank you.